All right, so let's get on to the top right here. This is the word, porphyrin. And porphyrin is any of the class of pigments. Everybody know pigments basically like the color of your skin and all that, from yellow to black, including hemi or chlorophyll, whose molecules contain a flat ring of four-linked heterocyclic groups, sometimes with a central metal atom. A central metal atom. Okay? So if y'all ain't paying attention, you got metal in your atom. Everybody have metals in them. So there's metal in the middle of your atom. And basically, it says sometimes that pigments can have metal in it. All right? That's basically what it's saying. So in the origin, it's saying that it means purple. Everybody know purple is significant with royalty. Okay? So now, this is a porphyrin class. This is how it looks, right? And you know, it already say about porphyrins, right? It say porphyrins are a group of heterocyclic microcycle organic compounds. Okay? Micro. Everybody know micro means big. Organic compounds, okay? It's a composed of four modified pyrrole subunits interconnected at their A atoms via methane bridges. The parent of porphyrin is porphyrin, a rare chemical compound of exclusively theoretical interest. I mean, they are interested in this. They don't really know about it that much, right? They're trying to learn. They don't know about it. Okay. So microcycle. A microcycle are often described as molecules and ions containing a 12 or more membered ring. Classical examples include the crown ethers, right? Collection rings or whatever, right? Crown ethers caught my attention, as you can see. And another thing caught my attention, right? You know, first of all, we know we're dealing with pigments, okay? Which is the polyphyrins, right? Or porphyrins. All right. So now the microcycles, right, which is the organic compound, microcycles are often described as molecules. Everybody know we made up of molecules. And ions, which is like the atmosphere and everything like that, okay? In the sky and everything. We breathe in ions and everything. Ions is what takes it exchange protons for neutrons, electrons, stuff like that. You know what I mean? You know, like when in ionization, you lose electrons and you gain electrons. You see what I'm saying, so to speak. All right, but anyway, that's another topic. I'm not trying to get y'all too lost on that. I'm trying to give you an idea. Ions is everywhere, okay? Basically, they're like energy, okay? So now, and it says containing a 12 or more membered ring. All right, classical examples include crown ethers. All right, so now, you know, my bad, y'all. I thought I was sharing it with y'all about the micro organic deal, but I wasn't showing it with you. Hold on. Let me show y'all what the micro organic is. I'm just talking. I mean the microcycle. I mean, y'all wouldn't get none of the game I was just giving you. But I mean, on the one I was telling y'all about the crown deal. Let me see if I can put it up for you so I can show you that what I was talking about. It's supposed to be showing for you. Let me see. But the one I was trying to show you, it ain't showing. Excuse me, which is kind of crazy. But anyway, I still go to it though, all right? So now, they say a microcycle refers to your season as a whole. A mesocycle refers to a particular training block with that season. You say, e.g., all right, the endurance phase, Okay, the endurance phase. Okay, all right. So it's a microcycle refers to the smallest unit within a mesocycle, usually a week of training. So, macro cycle dealing with the whole picture. Okay, now let me go to the crown ethers that I wanted to go to. Crown ethers. Okay. Now, this is a picture of the crown ethers, which is the same thing as the porphyrins, which is the same thing as pigment, and this is how it's shaped. These are the shapes of it. Okay, so crown ethers are cyclic chemical compounds. You know that kind of look like a ship steering wheel, like you know what I'm talking about. And they say compounds that consist of a ring containing several ether groups. The most common crown ethers are cyclic oligomers or ethylene oxide. I mean, the repeating unit being ethylenoxy. All right, but y'all get the drift. Y'all get the point with that, right? So now let's check out what ethers is real quick. Okay, let's find out what the ether is. All right. So let's check out ethers. So ether is a pleasant smelling, colorless, volatile liquid that is highly flammable. It is used as an anesthetic and as a solvent or intermediate in industrial processes. It's also any organic compound with a structure similar to ether, having an oxygen atom linking two alkyl or other organic groups. Okay, so doing the linking, keeping everything together. Okay, so the origin of the word ether is late Middle English from Old French or via Latin or via Latin from Greek, meaning upper air. Okay, the upper room. All right, they say from the base of everything burn, shine. All right, you know everything about burning something up. It's about the shine, about that light. Originally, the word denoted a substance believed to occupy space, what? Beyond the sphere of the moon. Now, understand that now. It's originally, right? The word was denoted as a substance believed, which they try to say they don't really know for sure, but hey, they just trying to describe what they say. Okay, believed to occupy space beyond the sphere of the moon. Okay, ether in the third sense, and it said rose in the mid 17th century, and ether since one in the mid 18th century. All right, so we get the origin again, and they referred to the space beyond the sphere of the moon. So now understanding that we're talking about crown ethers, and the crown ethers is something that is a part of your pigment. So therefore, though, if you have these crown ethers that has the metal inside of them and everything like that, quite possibly you are connected with the part of the atmosphere that is beyond the moon, the space that is beyond the moon. You understand? And the space that is beyond the moon, which I guess would be out of our immediate atmosphere, is the place where ionization takes place. Okay, let's see. Let me see if I can put it up for you right quick. See, if you know anything about the northern lights and all that, that's just a combustion of the ionization. Okay. Ionization. Oh, I forget exactly what I was about to look up just then. My bad, I had a brain freeze. Okay. Ionizing part of the atmosphere. Ionizing. Let's see. Ionizing part of the atmosphere. Which part is that? Okay, and that's the ionosphere. Okay, which that's the part that we're in. Okay, so now understand this now. The ionosphere is the ionized part of Earth's upper atmosphere from about 48 kilometers, 30 miles up, okay, to 965 kilometers, 600 miles altitude, a region that includes the thermosphere and parts of the mesosphere and exosphere. Okay, let's say the ionosphere is ionized by solar radiation. Now, understand what's going on here now. It says the ionosphere, okay, which the part where all the ionization takes place, which the part of space that is above the moon, okay, which is still in Earth's atmosphere. So they let you know the moon and all that type of stuff is in our atmosphere. And it's no more than 30 miles to 600 miles away. All right. So now it says the ionosphere is the ionized part of Earth's upper atmosphere. Right? It's still in our atmosphere, but it's in the upper part of our atmosphere. It says from about 48 kilometers, which is 30 miles, and it stretches all the way out. I guess it began at 30 miles up, and then it stretches all the way out from 960 kilometers, which is 600 miles altitude. A region that includes the thermosphere, okay, which is another part of our atmosphere, or not our atmosphere rather, but the atmosphere period. Anyway, and parts of the mesosphere and exosphere. The ionosphere is ionized, right? Another key part, by solar radiation, which is the sun. So the sun ionizes, part. Okay, it's ionized by solar radiation. Anyway, I don't even want to touch on that. I've been went left on y'all right quick, but that's pretty interesting to know, and so that y'all understand how this connect. So again, we know that our body ionizes, okay, through the cellular structures and stuff like that. And you know how they say, as above, so below. That's the key point. To have you to realize it's as above, so below, as within, so without, and it's on a reversal level when it comes to, everything out. The farther you look, you can see outwards is the most inner parts of yourself. Okay. And so that you understand that the more you vibrate in your micro cells, your microcycle, as a whole being, the more subsequently and consequently, the space above the moon will also radiate at a higher vibration, strengthening your being, strengthening the being that's connected to you. And then once you start exploding with this ionization, your light can spread out to others, and you may be able to affect others around you. Not to go too left on y'all, okay? But understand that this is all dealing with you and your cellular structure, your atoms, and all that. When we're dealing with the crown ethers, okay? So let me go back to the crown ethers again. That's just so interesting that they call it crown ethers, and that's something that's inside of you, man. The ethers inside of you, the seven heavens. The seven heavens. All right, again, just so y'all can see, you gotta. This is how the geometrical shape of the crown ether looks, and this is a part of your chemical makeup. All right. So, for sure. Until next time, I'll holler at y'all. Peace.